In this video, I'd like to talk about the concept of dividing powers. So basically, what I mean by this is that let's say we have 2 to the fourth and we divide it by 2 squared. So dividing powers is essentially looking at these expressions where you have two different exponent terms, 2 to the fourth up top and 2 squared down below. And we're going to be doing division. And the common theme with these expressions is that their base is the same. So what I mean by the base is this 2 in both of these expressions, or here the base would be the letter b. So in this case, it's actually a variable. But when they have the same base and they have different exponents, the general rule is that you'll take the exponent in the numerator and subtract the exponent in the denominator. So in this case, you just go back 2 squared. But with all of these problem types, you don't want to just memorize the rules. You want to understand them from basic principles. So let's rewrite 2 to the fourth by just taking 2 and multiplying it 4 times. So 2 to the fourth is just 2 times 2 times 2 times 2. And 2 squared means take this number and multiply it that many times. So 2 multiplied twice, so 2 times 2. And from here we can make cancellations. Since 2 divided by 2 is just 1. I'll just write that up here. Anything divided by itself is 1. So that is 1, and that is 1. And 1 times anything is itself. So you just end up with 2 times 2, which we can rewrite as 2 squared. So you can see that this rule that I mentioned, this general pattern, will work if you think it through with general or basic principles. So in general, let me just write out the rule. If you have a to the x power, and you divide it by a to the y power, notice they have the same base, but different exponents. And they could be the same exponent. This would still work. But as long as they have the same base, that's the important part. And when you're doing division here, you would just subtract the exponents. So you get x minus y. When you do multiplication, remember from that video, we end up adding the exponent. So recall that if you had a to the x times a to the y, that in this case you just add. And you might not notice it, but these are actually the same rule. Because if I take this expression here, I can rewrite a to the y using a negative exponent and bringing it up top. So this becomes a to the x times a to the minus y. Since we know that a to the minus y is just 1 over a to the y. Remember, if you have a negative exponent, then you put it in the denominator and make it positive. Negative exponents essentially mean divide by y that many times. Negative exponents essentially mean divide by a that many times. So when we rewrite it using this negative exponent, then our addition rule right here kind of applies. You have a to the x times a to the minus y. You would just add the exponent since we're doing multiplication here. So you get a to the x minus y. So you still get the exact same expression, the exact same answer. So both of these rules are essentially the same thing, just different ways of thinking about it. So let's go back and try and solve our problem now. We have this b to the 10th divided by b to the 6th. And we'll start by thinking about it with our basic principles. B to the 10th divided by b to the 6th. Now b to the 10th just means take b and multiply it 10 times. So I'm going to write it out for this first one, but generally with these higher exponents, this can be a little bit tedious. So I won't always do this in practice, but for now, it does make sense to do it. So that should be 10, yep. And then we're going to divide it by b to the 6th. So that's b multiplied 6 times. So 1, 2, 3, 4, 5, and 6. And then we know that when we divide something by itself, b divided by b, this is just 1. So these cancel out to make 1, so do these do. And essentially, you're going to get 6 pairs of these canceling out. And so in the end, you just have 4 left up top. This is the only thing that did not cancel out. And so this simplifies to b to the 4th power. But notice that matches up with the rule. Since they had the same base, you took the top exponent and you subtracted the bottom exponent. And so what you'd put in the box, since we want it in the form b to the n, you would put in b to the 4th power here. So let's look at some more examples, just to get a little bit more practice. So we have 4 to the 9th, and we're going to divide it by 4 to the 5th power. So rewriting that, 4 to the 9th divided by 4 to the 5th. So up top, you're going to have 9 of these 4s multiplied together. And down below, you're going to have 5 of these 4s multiplied together. So let me write that out really quickly. And you can see with 9 up top and 5 down below, we can start making cancellations, since we know that 4 divided by 4 is just 1. So these cancel, these cancel, these cancel, those and those. And so in total, you would just have these 4 left. So this simplifies to 4 to the 4th power. But again, this matches up with our rule. Since they have the same base, you can just subtract the exponents. 9 minus 5 would give you 4. So in this box, you would put in 4 to the 4th power.